Application of derivative. So derivative is dy dx. y is equal to fx is a real valued function. This is dy dx. So there are many applications of derivative. We'll discuss about tangent and normal to a curve. So tangent and normal, it is this one. So dy dx at x1 y1, it is the, we draw a tangent to the curve y is equal to fx. So at that particular point, this is the, if p is a point x1 y1, then this dy dx at x1 y1 will mean the gradient. So this tangent means this is a straight line. So this is having an angle made with this x-axis, and this tangent of this angle is the gradient of the line. So if it is theta, then tan theta will be equal to this one, dy dx at a point x1 y1. So this is gradient of the tangent, and gradient of the normal is, it is mutually perpendicular. So if it is m, then it is m1, then n, so that m into m1 is equal to -1. So in this way we find this one. So this is m, then it will be -1 by m. So tangent is y minus y1 by x minus x1. This is equal to gradient, and normal is y minus y1 by x minus x1 is equal to -1 by m. So this is from this one. So this is mx plus c, gradient is, and this is -1 by m x plus c dash, perpendicular line. So this is then angle between two curve. Angle between two curve is, it is, to find this angle we need this gradients of the line, and gradients of the line we must know the derivative at that particular point. So that is why we require it to find angle between two lines. Then second order derivative. Second order derivative is, it is second order. So d2y dx2, d2y dx2, it is derivative of dy dx, and this is necessary for finding extreme value of function. So to find extreme value of function, we need to find a value for second order derivative. So these are extreme values, a, b, c, d. So a is maximum at this neighborhood, not lowest, because a is less than c or a is less than d, but this point is maximum. At this point it attains maximum for this neighborhood. Similarly, at this neighborhood b attains minimum, like that. And for this, to find the maximum minimum, we need to find this second order derivative. So the rule to find maximum and minimum value is, this is rule. So dy dx is find dy dx and d2y dx too. Then solve it for the for root at what point it is, because dy dx 0 means what? This angle is, this line is parallel. So it is parallel. So so it will not, it is upward, then it is downward. So at this point it is extreme value. So we need to find this point at where this angle is 0. It is parallel to x-axis. Then after finding the roots, then we find d2y dx2 for x1. If it is positive, then it is minimum. If it is negative, then it is maximum. And if it is 0, then we cannot have the value, extreme value. And then these are some examples for rate measure. dA dt, it is rate of change of area. So this is area of area A of a square of side A. So dA dt means with respect to time, the rate of change of area. This is a problem where radius is changing. So dr dt, rate of change of r, it is given. Then in what rate it is, circumference is changing. So these are some examples of this. This is speed of this hour away lamp post it is. So this is also some speed to measure the speed of the this shadow, in which length is increasing, how it is increasing, in which speed it is increasing. So then a particle moves in this point of the curve at what coincides so rapidly x coordinate. So how it is moving, the rate of change of y with respect to time. This is find a point on the curve, the rate of change with some rate. So these are all rate of change. So from these examples you can find these things. This balloon in the form of right circular cone, then how fast the volume is changing, so you need to find volume of this, etc., etc. So these are all about rate of change. Then this is surface area of this, and this is one kite is flying. So this is an example. Then circular disc, it is how it is expanding. Then this tangent, these are problems from tangent normal. The tangent normal, so slope of tangent, find the slope of tangent and normal. So you find dy dx. So slope is this dy dx at a point 1 1 we find. So this is slope of tangent, slope of normal. This is proof that the tangent are at right angle. So tangent, we find gradient of the tangent, then gradient of the tangent at 2 0, gradient of the tangent at 3 0, and their product is this -1. So the two gradients are the angle between them is 90 degree. Then find the slope of tangent. This parametric equation. So parametric equation, we are finding this slope dy dx. So it is dx d theta, dy d theta. Then we find this value. Then this is also equation to tangent. Then equation that we have to find equation to tangent. This is parametric equation. So we find dy dx. Then we write the equation y minus at the point t equal to -5. So t equal to -5, these are the values. So these are the equation. Then find equation of tangent and normal. So these are all by formula. Just to find dy dx, define dy dx, then dy dx at that particular value, and we write the equation y minus 0 by x minus, etc., etc. So these are all about tangents and normal. Then these are all explained here. We can have it. Then this is also tangent normal problem. These are all tangent normal problem. These are, so these things I have done, I have solved it, but sometimes there may be some calculation mistake or maybe some copy paste mistake. So you do it on your own and check it. So these are all equations, simple things, simple only formulas we are applying here. So angle of intersection, the angle of intersection means it is we find m1 m2 and then tan theta, so tan phi. So angle, it is phi is pi by 2 because this gradients. So dy dx at 0 0 it is infinity, dy dx at 0 0 it is 0. So there, so you see dy dx, if we have this dy dx value is infinity, means what? It is tan of theta is infinity, means tan theta is infinity when theta equal to pi by 2. So and when it is 0, then we write theta equal to 0. So this is point of intersection. So all these are examples on tangents and normals. These are all this. Find the equation the tangent and perpendicular to this. So perpendicular equations are, so gradient is, so gradient it should be, because it is perpendicular, it should be 9. It is minus, this is slope of the tangent is, it should be 9. Y is equal to mx. Gradient is 9. Gradient xy is equal to tangent perpendicular to this, because it is minus 1 by 9, so it should be 9. So value is x equal to 1 minus 1, like this. Then second order derivative, we are finding these values. So dy dx, these are all done. Examples are done here. So taking so y is equal to x to the power x, we need to take log, then only we can have this, because there is no formula for x to the power x. So it is x log x, we are taking log, then 1 by y dy dx, then this is x in x, derivative of x is 1, is product function, it is x in 1 into log x plus x into 1 by x. So these are the things. These are all worked out problems, very simple problems. You can see the steps, you will have it now. So these are sin x cos x e to the power sin x cos x y is this. We are simplifying this actually, so that we can take derivative as simple. So these are all second order derivative. Second is a parametric function, second order derivative. This is, we need to prove this one. This is also application of second order derivative. So this one, then these are all examples. So a to the power tan inverse x into 1 by 1 plus x square, then 1 plus x square into dy dx. It is e to the power tan inverse x is equal to y. Then we take differentiate, so that because y2 means it is d2y dx2. So d2y dx2, so we need to find the second order derivative. So this for this we are taking d2y dx2, and we are having the result. Then this is also like it, d2y dx2 minus 2 dy dx plus 2y equal to 0. It is satisfied. So these are all those things. E to the power y x plus 1, prove that d2y dx2 is this. So we find d2y dx2, then dy dx whole square, it is same value. Then extreme value of function. So to find extreme value, maxima minima. So maxima minima rules are there. We need to find dy dx, then d2y dx2, then we make dy dx equal to 0. We are finding this rules, x equal to 3, x equal to 1. Then at x equal to 3, x equal to 1, we test it, this one. So because it is positive, so f3 is minimum. Because it is negative, f3 1. So f3 is 6, f3 is minimum. Then minimum value is this, then minus 6 at x equal to 1. So this one is f, hence f3 is maximum. No, not f3, this one is 1. This is f1. This is f1 is maximum. So this f1 is this one, so minus 4. So there are also, all these are examples. So this dy dx is 0. So 2 cos twice x is 0, means twice x is equal to this is solution of cos twice x equal to 0. So it is x equal to pi by 4, thrice pi by 4, etc. Because x is given as lying in between 0 and pi. So we find this value. So maximum, it is at pi by 4, it is 1. At 3 pi by 4, it is minus 1. So these are the examples of extreme values. Y is equal to sin x plus cos x. So these are these values. Then dy dx is minus sin x minus cos x. So dy dx, d2 by dx2, the many values are here. 5, because it is fifth degree, x square cube, fifth degree. So these are the values. So 2 zeros, 2 half, and 1 4. So we are testing it. So f1 by 4 is minimum, f2 is f2, where is this? Not this one. So f1 by 4 is maximum, but 0 0 and half half, it doesn't have any value, it is 0. So we cannot have extreme value here, because d2 by dx2 must be non-zero to have an extreme value. So only 1 by 4 works, and it is minimum. Then these are some examples. So this is also neither maximum nor minimum, because d2 by dx2 is 0, so no extreme value here. Then this one is maximum is less than minimum here, x plus 1 by x. Then so this is also maximum value, minimum value. Then this is a statement problem. 64 into 2 parts, cube of the parts, cube of 2 parts is minimum, sum of the cubes of 2 parts is minimum. So 64 2 parts, so one is x, other is 64 minus x. Then we are sum of these cubes. So our function is this. Then we find dy dx and we find the values. So we get the value as minimum, it is 32. The two numbers are 32 and 32, half of this. So these are all examples of this combined resistance R of two resistors. So R1 plus R2 is constant, so we are testing it for this extreme value. Maximum is when the two resistors are equal value. So these are all examples here. So this is one example. A rectangular base is open at the top. So what is the cost of least expensive tank? Means we have to find base area. So side total cost is this. So cost is for this construction. So how we are finding the cost? Total cost is this one. It is depends on the dimension. So x, y are the dimension. So this cost rupees this per square meter. So we need the dimension of this. So this minimum cost is rupees 1000. So these are the examples for this extreme value of this derivative of function, application of derivative.